Hello everyone, I hope all of you are doing well. Welcome to this lecture of the feed milling training of the Soy Excellence Center, and this is the basic level. During this presentation, I am going to talk about principles of pelleting. We will discuss the benefits of pelleting in animal performance. In addition, we are going to discuss the different components of the pelleting systems, and we will discuss the role of each of those components on overall feed quality. And in a nutshell, pelleting is a process during which individual ingredients or mixed feeds are agglomerated using heat, moisture, and pressure. So you start with mash feed and then you end up with a pelleting feed. Sometimes, and in the context of this presentation, I'm going to focus on pelleting mash feeds. But remember that individual ingredients can also be pellets, and sometimes these ingredients are pelleted to reduce dustiness, increase density, and also increase the amount that can be transported. But for the context of this presentation, we will focus on mixed feeds that are going to be pelleted. And pelleting is a very expensive process and can cause a lot of headache. If you go to any feed mill, you are going to realize that the area that requires the majority of time and money or the process is going to be pelleting. Pelleting is the major cost center in feed manufacturing. And here you can see this data from 2008. This is data from one feed mill in the US, and you can see that the total cost to process 1 ton of feed at that time was $7.32. Right now, this probably is over $10 per ton of feed. So what this means is, like, if you have a feed mill that produce, let's say 10,000 tons per week, then that feed mill is going to be spending about like $100,000 in cost. And these costs are going to include labor. This is the payment of the employees, electricity. Then you are going to have expenses in gas and oil, and then you have the maintenance and repair, and this is going to include preventive maintenance and corrective maintenance, and then you have some miscellaneous and then some depreciation. But in this table, what you can see is the total cost, but pelleting is gonna represent maybe 40% of this total cost. Even though pelleting is an expensive process, there are several benefits of pelleting that compensates the cost of pelleting. Some of the benefits of pelleting include the reduction in nutrient segregation, because once that mixed feeds are agglomerated, they are not gonna separate. Typically, if you have mash feed, the coarse particles are gonna segregate from the small particles, or the particles that are denser than others are gonna also segregate. We also reduce selective feeding with pelleting. If we give the possibility to the birds to choose different particle sizes, most likely they are going to pick the particle sizes that are going to be between 2 and 3 millimeters. And those particles might be big pieces of corn that will have a high energy content but a low digestible amino acid content. But when we put all the feed into a single pellet, then we make sure that the animals are getting all the nutrients in every single bite. In addition, when we pellet, we also reduce feed wastage, and this is the feed that falls in the litter. So if we have issues with feed wastage, the problem is, like, we are going to have a lot of undigested nutrients in the litter, and then the bacteria are going to be able to use those nutrients, produce ammonia, and then that can lead to respiratory problems, blindness, also can lead to foot dermatitis issues, etc. With pelleting, we can reduce that feed wastage. Also, pelleting can help to reduce the microbial load in the feed. We know that the ingredients are going to contain a little bit of background bacteria, and during pelleting, these bacteria can be reduced. In addition, with pelleting, we can improve average daily gain. We can improve feed efficiency because the birds can consume the pellets faster, so they can spend more time resting and less time eating. In addition, we can improve bird uniformity because if the birds are able to consume the feed faster, then they are going to leave more space in the feeder to other birds. Also, we can improve resting time and palatability. However, one of the main reasons to pellet poultry feeds is to increase feed intake. To illustrate the improvements of or the benefits in feed intake, we will use these two birds as an example. And let's assume that the maintenance requirement of these two broilers is to 100 kcal of metabolizable energy per day. Then you have this broiler in your left that is consuming much diet, and it has an intake of 200 kcal of meat per day. This broiler in your right is going to be consuming pelleted diets and can consume 300 kilocalories of meat per day. So my question for you is, which broiler do you think that will have a higher average daily gain and better feed efficiency? So the ones that answer that, the broiler in the right will have higher average daily gain and better feed efficiency are correct, because this bird here on the left is going to be using 50% of the calories for maintenance and 50% of the calories for growth. And when I'm talking about maintenance, I'm talking about like thermoregulation, immune function, respiration, heat dissipation, etc. This broiler, because it's consuming a higher level of energy, is going to be using 33% of the calories for maintenance and 67% of the calories for growth. So this broiler is going to be way more efficient than this one. And I'm just using, like the example of energy here, but this can be applied to all the different nutrients. This broiler is going to be consuming more digestible lysine and more digestible amino acids than this broiler, so it's going to have more fuel for a meat accretion. And here you can see the different components of a pelleting system. You can see here, this will be the mash bin. Then you have this feeder, and this feeder has a variable speed motor to control production rate. However, this motor also monitors the motor load of the main motor in the pellet mill, and if the motor load in the main motor is too high, then the feeder motor is gonna slow down just to maintain the balance in the pellet mill. Also, here you can see that this pellet mill has a double conditioner. However, there are gonna be some pellet mills that are gonna have triple conditioners or single conditioners. But as you can see here, the steam injection is at the entrance of the first conditioner. The second conditioner in this case is just for tension time. Then you have here the pelleting chamber, and then the hot pellet leaps to the cooler. And here you can see the whole animation of the process, and you got here the mash entering the feeder. As I mentioned, the feeder has a variable speed. Then at the end of the feeder, the feed is gonna fall by gravity into the conditioner, and then we start injecting steam here in the conditioner. And then retention time is very important in this conditioner. You would like to get at least 45 seconds retention time in the conditioner. And then at the end, again, the conditioned mash is gonna fall by gravity, and then it's gonna enter the pelleting chamber. And as you can see in this pelleting chamber, you have a die that is turning to the right, and then you have some rolls inside. And as we compress the meal between the die and the roll, then we are able to produce these whole pellets. And there are different factors when we are pelleting that are going to influence pellet quality. So for example, formulation typically represents or influences 40% of pellet quality. So if you have the opportunity to add wheat, for example, 10% wheat to 15% wheat is going to help to improve pellet quality. Particle size will also influence pellet quality, and if you have a small particle sizes, those are going to hydrate better, and they are going to tend to improve pellet quality. However, as I mentioned to you in a previous presentation, you shouldn't sacrifice particle size if you are producing poultry diets. If you are producing swine diets, you can get the benefits of both worlds. With a small particle size, you can increase digestibility, and also you can increase pellet quality. In broilers or poultry is different, because if you reduce the particle size too much, especially if you go less than 700 microns, then basically that's not going to help with gizzard development and reverse peristalsis. Also, feed conditioning is going to influence pellet quality around, in this case, 20%, then the dye 15%, and then drying and cooling 5%. So these are going to be the main factors that are going to affect pellet quality. However, you need to also evaluate other factors. For example, the amount of fat that you add in the mixer. If you increase the amount of fat in the mixer more than 1%, that is going to help you with throughput, but it's going to affect your pellet quality. In addition, throughput can also influence pellet quality, because if the throughput is too high, then there is going to be less time for the compression of the feed in the pellet die. And there are going to be some pellet quality factors that I think is important that you understand, because you might be making different type of feeds. But for example, if you have feeds that have a high content of protein, this is going to be good for pellet quality and for pellet meal capacity. So if you look the pellet durability of your feeds, most likely the highest quality is going to be the starter feed, because this one contains more protein and contain less energy, so it's going to contain less added fats. Fat content is not good for pellet quality, but it's going to be excellent for capacity. And then the fiber content is going to be okay for pellet quality. Typically, when you have ingredients with a good content of fiber, they tend to improve pellet quality, but they are not very good for capacity. And this is because fiber doesn't accept the steam readily. So if you have diets that contain more fiber, and then you are pelleting those diets, then you need to find alternatives to increase retention time in the conditioner to allow those particles to hydrate better. And in this particular experiment, you can see the effect of a fat addition on pelleting production characteristics. So the total added fats for this particular example was 5.7% fats, and then a percentage was added in the mixer and the rest was added post pellets. So you can see here in the first treatment, only 1% was added in the mixer, then in the second 2%, 3%, 4%, and 5.3%. And then the difference was added post pellets. Once that you evaluate the pelleting production characteristics, you can see that adding 1% fat in the mixer led to an improvement in the level of fines. These diets only contain 12% fines. However, as the level of mixer added fat increased, Then there was also an increase in the percentage of fines in the finished feed. And when you evaluate production rates, you can see that increasing the amount of fat added in the mixer increased production rates. In this case, between 1% and 4%, there was an improvement in production rate from 11.6 tons per hour to 13.2 tons per hour. And when you evaluate the energy consumption in kilowatts hour per ton, also you can see that as the level of fat in the mixer increased, then there was a decrease in energy consumption. And this makes sense because remember that fats are lubricants, and then when you got fat in the mixed feed, that fat serves as a lubricant in the pellet die. So it helps with the throughput. The problem is, like, as the pellets leave the die, they are not going to be good quality, so they are going to start breaking apart, and then they can produce fines. Also, if you have like a feed mill that produces, like feed for piglets, most likely you are going to have a diet that is going to contain a lot of sugars. These sugars are going to be heat sensitive, and the idea here with these diets is to maintain a low conditioning temperature. You don't want to go above 65 Celsius degrees because this sugar is going to make like a cookie in the pellet die, and then you are going to plug the pellet mill. And a good practice here is to make sure that like the system cools down before you start making those diets. Also, like there are some sources of phosphorus that are gonna be great for polishing the die holes. So, for example, defluorinated phosphate can be used to polish the die holes, and that helps with the throughput. However, these phosphates are going to be more expensive than other sources. Also, if you are making feed for cattle and then you have a high mineral formulas, then a good idea is to use thinner dyes and dyes with a higher chromium alloy. Also, moisture content is essential for pellet quality because moisture content helps with the heat transfer. Here you can see another example, of different factors and how they affect pellet quality. And this study was conducted by Winnow Whiskey. And then here you got a control treatment, and the PDI of the control treatment was 70%. However, when the conditioning temperature increased 5 degrees Celsius and then 10 degrees Celsius, then you can see an improvement on pellet durability index. When the amount of fat in the mixer was reduced to 0.5, then there was an improvement in pellet quality. And then when you add some pellet binders like calcium lignosulfonate, there is an improvement in pellet quality. In this particular study, as you can see here, that decreasing production rate didn't influence pellet durability that much. However, adding 10% width help with the pellet durability index. However, remember that typically the cheaper option is to increase conditioning temperatures, but you need to make sure that you are not overheating the feed. So now we can discuss the different components of the pelleting system. And the first component that I'm going to discuss is conditioning. And as you can see here, as the feed leaves the feeder, it falls by gravity into the conditioner, and then you got like some steam addition in the back. So the purpose of conditioning is to soften feed particles and also to activate natural binders. When feed is conditioned, proteins and starch structures are changed, and then they can serve as glue or as binder. And remember that you need some of this moisture to create these solid bridges. If you have heat but you don't have the moisture, then you are not going to be able to create these solid heats, and that can affect pellet quality. Also, when we add water, water serves as a lubricant in the pellet die. So you are going to see a decrease in the friction in the pellet die. And the way that you measure this friction is by collecting a sample of the conditioned mash, and then you can collect a sample of the hot pellets. And then the difference in temperature is going to be due to frictional heat in the pellet die. Also, when you are conditioning diets, retention time is very important because this will allow for greater steam penetration into feed particles. And typically, as a rule of thumb, for every 15 Celsius degrees that you increase the temperature of the meal, you are going to add 1% moisture. For example, if you have mash, cold mash, leaving the mixer at 25 Celsius degrees and at 13% moisture, and then you want to take this 25 to 85, then you increase it 60 Celsius degrees. So if you divide 60 divided by 15 Celsius degrees per percentage of moisture, then you are going to calculate that you added roughly 4% moisture in that feed. And there will be several factors that affect conditioning. One of the factors is going to be the mash particle size. And as I mentioned before, surface area increases as particle size decreases. The other factor that is going to influence conditioning is retention time. You want to maintain a retention time between 45 and 60 seconds for optimum pellet quality. The other factor that is going to affect retention time is the peak angle, and the retention time decreases as forward angle increases, which makes sense. If you are moving faster that feed out of the conditioner, then your retention time is going to be lower. Also, there are going to be some conditioners that come with VFDs, and then you can change the chaff speed, and in that way you can control the filling of the conditioner. Also, the water addition can affect conditioning. The optimum conditioning target is going to be between 12 and 12.5% moisture, but this is going to depend on the thickness of the pellet die. If the dies are thicker, then they are going to accept less moisture compared to thinner dies. And you want to add around 4% moisture in the conditioner. And remember that conditioners should be around 60% full, and this is what you can see in this picture. And as you can see in this picture, there is like a mountain inside the conditioner. And this is important because if you are injecting a steam in this side of the conditioner, and then the steam is gonna try to move to the path of less resistance. So if the conditioner doesn't have a section that is full, then this steam is just gonna go over the meal, and then it's gonna cool down in the other side, and then it's gonna start precipitating. And the issue with that is that you got the pellet mill below, so the pellet mill is gonna be receiving feeds with different moisture content, and that can affect the production rate and the efficiency of the pellet mill. Also, as I mentioned before, if you don't have a VFD, you can change the angle of the peaks. And a good idea is that every time that you make a change, you should monitor the motor load. Because if you make a change and then you are retaining for longer time the feed in the conditioner, then your motor load is going to go up. Also, remember that increasing conditioning temperature and time can improve pellet quality, but this can have a negative effect on exogenous enzyme and heat labile nutrients. So you need to maintain a good balance. I'm going to give you my recommendations in another slide. But the other thing is that if you make drastic changes in the conditioning process, then you should evaluate the stability of exogenous enzymes to make sure that you are not damaging those enzymes. And here you can see the peak paddle angle, and then a 45 degrees setting is going to be for maximum conveyance, as you can see here. And 0 degrees will be parallel with the shaft, and then this is going to be for maximum mixing. When you make changes in the peaks or paddles, I will advise you to just move 1 or 2 paddles at the same time, and then monitor motor load, and then also monitor pellet mill, efficiency. And steam quality is very important because you are going to use steam during the conditioning process, and this steam quality is the amount of moisture in the steam, and this is going to affect the amount of heat and moisture that is transferred to the feed during the conditioning process. So if you have low quality steam, then this means that the steam has a lot of moisture and not enough heat transfer, and can result into a reduction in production rates. This can lead to choke die, plugging, etc. If you have high steam quality, this means that there is not enough water in the steam. And if there is not enough time in the conditioner, then there is going to be poor gelatinization of the meal, of the starch in the meal, and it's going to be poor denaturation of the proteins. So you need to monitor steam quality. And if I recall correctly, good steam quality is going to contain about 97% steam and 3% water. And in the conditioner, retention time is very important because this allows the moisture and the heat to migrate into the core of feed particles. However, most feed mills are already configured to have single, double, or triple conditioners, and sometimes the only option to modify retention time is to adjust the angle of the paddles or to use variable frequency drive in the conditioner motor. Conditioning temperature is easier to modify by adjusting the steam flow rate into the conditioner. So these are some of my recommendations regarding conditioning. The temperature should be between 82 to 88 Celsius degrees. And if you go more than 88 Celsius degrees, then the risk that you have is that you might be damaging some essential nutrients in the feed. Moisture content between, let's say, 16% plus or minus 0.5. And then remember that for every 25 Fahrenheit degrees or 14 degrees increase in the conditioning temperature, there is an increase in 1% moisture. And like depending on the quality of the steam, this might be, for every 27 Fahrenheit degrees or 15 Celsius increase in the conditioning temperature, then you add 1% moisture. But as you can see in this slide, in this graph, this is one of the projects that we did with one of my undergraduate students. And you can see here that as conditioning temperature increases from 60 to 90, there is an increase in the amount of moisture in the meal. And when I'm doing, like presentations about conditioning and pelleting, one of the questions is like, what is the optimum conditioning temperature? And in reality, there is not a fixed value. And the optimal conditioning temperature is going to be influenced by other factors, such as retention time in the conditioner. For example, if you have like a single conditioner and then your retention time is only 15 seconds or 20 seconds, then you might need to add more temperature. However, if you have a double conditioner or a triple conditioner, then with 82 to 88 Celsius degrees should be enough to get good pellet quality. In addition, you need to consider the amount of fat addition in the mixer. I told you that fat works as a lubricant, so if you have more fat in the meal, then the system is going to be able to tolerate a higher temperature without plugging. Also, weather can make a difference. However, you need to remember to evaluate, the stability of some critical nutrients. For example, when you increase the conditioning temperature more than usual, then you should collect some samples to analyze, enzyme stability. And also, you can evaluate vitamins stability, but when you are analyzing enzyme stability, what you need to do is collect a sample after the mixer to have a baseline concentration of the enzyme that you are applying. And then you can collect samples after pelleting, even after conditioner, and then you can see how much enzyme you're losing. And then you can take a decision of, reduce the conditioning temperature slightly, or you can add more of that enzyme in the formulation to compensate for the losses in the conditioning process. So another question that we typically get is how much steam can be added. And then you need to consider what will be the beginning temperature and what will be the beginning moisture. And to know this, you need to collect the samples after the mixer, because you can plug the pellet mills two ways. You can have a dry choke, and in this case, feed rate exceeds die capability. So this is an issue with higher amps. And then wet choke is when you have too much moisture to push through the holes. And this, what occurs in the pelleting is like when you are driving in a muddy place, and you can get stuck because there is not enough traction in your tires to move the car out of the muddy area. The same occurs with pelleting. Like if you have like too much moisture, you are going to have a roll slip, what we call a roll slip. Don't forget that phrase. And then that happens when there is too much moisture in the mill. Also, you need to evaluate, your steam quality. As I was telling you before, if you have a poor quality steam, then you are not going to be able to add much of it before you plug the pellet mill. One thing that I was going to say is like, if you have problems with a poor steam quality, then you need to check the steam traps in the feed mill. Make sure that the steam traps are removing the condensates, and also you need a good isolation of the steam transfer system from the boiler to the pellet mill. Feed formula is also going to influence. There are going to be some formulas that they are not going to take as much steam before they create a roll slip, so you need to know that. Dye specification also going to influence how much steam. And in my experience, if you have like thinner dyes or dyes with a lower compression ratio, then they are going to accept more steam. And also the humidity too. And this is a very important slide, because you can use this information to evaluate the quality of your steam. And this is very simple to do. You need to collect a sample after the mixer, and then you evaluate the temperature, and then you evaluate the moisture content of this sample. Then, when you are pelleting that feed, then you can collect a sample after the conditioner, and then you can evaluate the temperature and then the moisture content. And as you can see here, the mash temperature was 23 Celsius degrees, then the conditioned mash was 83 Celsius degrees. You can see that there was a difference of 60 Celsius degrees. When you look the moisture content, the moisture content increased from 12.5 to 16.5. So the increase was 4%. So if you divide 60 divided by 4, you find that they have a relationship of 15 to 1. So this will be an indication that the quality of the steam is good. However, when you are collecting these samples, you need to collect these samples correctly. And this is what I want to explain. If you are evaluating the temperature of the conditioned mash, you need an insulated container to evaluate that temperature. So what I typically do is like I buy like these thermos containers, and then on top the cap is plastic. So you can make a hole small enough just to put a thermometer. And then when you are collecting the temperature of the conditioned mash, then a good idea is to pre-warm the container, then drop the sample and then collect a new sample. And then in that new sample, you can evaluate what is the temperature of that sample. And you want to use a completely insulated container, because if you don't do it this way, then some of the temperature is going to start leaving the container, and then you are going to underestimate what is the temperature of that sample. And when you are collecting moisture content for this same sample for the conditioned mash, my recommendation is to collect the sample, put it in a container that is hermetic, and then seal it. And then you have to wait until the samples cool down completely. What you are going to see is like all the moisture is going to start condensating in the particles. And then you can analyze the moisture content, because if you try to analyze the moisture content in a hot sample, then all that moisture is going to start migrating into the environment. And again, you are going to underestimate the level of moisture. So this data, as I mentioned, is good to evaluate what is the quality of your steam. However, when you are collecting these samples, you need to be very careful. Use an insulated container, and also for moisture, you need to seal and cool down the sample before you analyze it. Now, I am going to show you like 3 different ways to evaluate conditioning time. And one way is the amp load method. Basically, what you do here is you stop the feeder, and then you stopwatch until the pellet mill is close to the idle amps. You can do it, different times, and then you are gonna get like an average retention time. The other alternative is whole corn die method. And then here what you can do is at the discharge of the feeder, you can add, the whole corn and the die method, and then you collect a sample at the end of the conditioner as it is entering, the pellet mill. So basically, you are putting a color here, and then you are monitoring how long does it take for that color of that corn to get to here. Then the last alternative is to weigh the conditioner contents. So to do this, you need to know what is the tons per hour that the pellet mill is running. And then what you need to do is you stop the feeder and the conditioner. So everything stays in the conditioner. And then if you know that you are running the pellet mill at 50 tons per hour, then you know that you are running at 100,000 pounds per hour, because you multiply 50 times 2,000, then you get 100,000. Then you can divide this 100,000 pounds divided by 3,600. So basically that will be the number of seconds in 1 hour. And then you can calculate how many pounds are going per second. So this means that if you are running at 100,000 pounds per hour, then you are running that pellet mill at 27.8 pounds per second. So if you collect 1,750 pounds in the conditioner, then you divide 1,750 divided by 27.8, and then you get a retention time of 63 seconds. So hopefully that makes sense. If you do the math several times, it's going to make sense. This will be the most accurate way to calculate your retention time. But as you can see, because you are stopping the conditioner, it takes longer time. So this is something that you can do maybe twice a year. This is not something that you will need to do like every week or every day. And conditioning is extremely important. I was telling you that as you increase conditioning temperature, you improve pellet quality. And we did this experiment in my team, and we were increasing the conditioning temperature from 160 to 170, 180, and 190 Fahrenheit degrees. This is basically 71, 77, 83, and 88 Celsius degrees. And then you can see that as the conditioning temperature increase, then there is an improvement in pellet durability index. Also, you can see that as conditioning temperature increases, there is a decrease in the percentage of fines. And when we were doing this experiment, we were bagging, 40 bags, we collect 6 bags during bagging. And then we weigh the bag, and then we weigh how much fines were in the bag and how much pellets were in the bag. And then you could calculate the level of fines. We did it this way because if you are just collecting a sample to evaluate the level of fines, then you might not be able to collect a representative sample. But when you collect the whole bag, then you have a better representation. But in general, higher conditioning temperature, better pellet quality, and a lower level of fines. And these are some of the maintenance items that you need to pay attention during conditioning. You need to check retention time that I show you how to do it. And also you need to check fill rate. And if you want to check fill rate, you just need to stop the conditioner and you need to open it. And what I was telling you is that you need to make sure that you got like a mountain of feed inside the conditioner. Also, you want to check peaks wear and confirm that peak paddles are secure, as you can see here in this photo. Also, you want to keep the motors clean, make sure that the belts have the proper tension, and also these temperature probes, then you need to make sure that they are clean, because if they have some build up, then they are not going to be able to record the temperature correctly. And if you want to increase retention time during conditioning, then you can use hyalinizers. And these hyalinizers are typically used by the genetic companies to produce salmonella-free feed. Because in the hyanizer, you can increase the retention time up to 5 minutes, and then that's gonna eliminate any salmonella that might come in the ingredients. So here in the hyanizer, basically what you have is like an auger, and then feed is moved through the unit by an screw auger, and it follows the principle first in, first out. Some of the features of this equipment is that they can help to increase salmonella control. They can help to improve pellet quality because there is going to be a higher retention time. Also, you have like flexible temperatures and retention times, and also this is gonna be steam jackets. That means that you can not add direct heats, but you can add some indirect heat. And the idea of the jackets is to make sure that you are not losing any temperature in the unit. And here you got like different models with the different times. However, one thing that you need to consider is that if you increase retention time, then you need to decrease production rate. For example, let's see like the biggest model, which is 48LL J16ST. At 2-minute retention time, you can run the system at 80 tons per hour. However, if you want to increase the retention time to 4 minutes, now you need to cut the production rate in half. And this is because this is a volumetric unit. So if you increase retention time, then you need to slow down production rate. So as the summary of this first part, remember, pelleting is expensive process, but improvements in feed conversion and nutrient digestibility compensate the added cost of the pelleting process. And the conditioning process can be used to improve pellet quality and pelleting efficiency. However, it is important to make sure that you are not overheating the feed, and also good manufacturing practices must be followed during sampling to obtain a representative samples during the process. And this is particularly important when you are collecting samples of temperature and moisture in the conditioned mash.